this video, we take a look at normalization and entity relationship diagrams, both a tutorial and a review of how to do those by looking at past Cambridge exam questions. So let's go ahead and let's dive right into it. With normalization, there are some things you need to know. And for computer science, it consists of 3 levels. First normal form, second normal form, and third normal form. Now on the exam, you may see it labeled as 1 in F, 2 in F, or 3 in F, but they all mean first, second, or third normal form. Now before we get into these, you must know what a primary key is, a composite key, and what a foreign key is. Now these keys, the primary, composite, and foreign keys, they're used to normalize databases and to create relationships between tables in a database. All right, first normal form. Each table to be in first normal form should conform to the following rules. Each attribute, which is simply a column, should be unique, and there should not be repeating attributes or columns or similar attributes in the table. Each attribute should contain a single value and not multiple values for a given row. So later today, you're going to see number of products in a table. There should be only one number, not multiple numbers in that attribute or into that column for a given row. So we'll talk more about that later on. Second normal form. Each table to be in second normal form should conform to the following rules. Well, you don't just jump into second normal form. It must already be in first normal form. Now, that's not an official rule, but you don't just jump straight into second normal form or third normal form. You follow the progression. Now, for second normal form, there should be no partial dependencies. Now, this means that all things that are not primary keys are fully dependent upon the primary key. There are no partial dependencies. Now, this is usually referring and seen with a composite key. And a composite key are two attributes or two columns that have been selected together to act as a primary key. So the attribute is dependent upon both of those items being selected, not just one of them. That's what it means by a partial dependency. Third normal form. Each table to be in third normal form should conform to the following rules. Should already be in second normal form, but the rule is there should be no transitive dependencies, and all non-keys are dependent upon the primary key. So we'll look at what a transitive dependency is later on today so you can understand those. Just by knowing the definitions may be able to get you a few points on the Cambridge exam. So we'll see examples of first, second, and third normal form later today. Now, we said you need to know a primary key and foreign keys. Now, each table should have a primary key where the attributes are dependent upon this key and only that primary key. It should be unique and it should never be repeated. So if I have a student table, student IDs would be my primary key. It's unique. It doesn't repeat because I don't need to put students into the table more than one time. Now, you can have a composite key which consists of multiple attributes. It's very important that when you get the second normal form that all non-keys, anything that's not a primary key, it's dependent solely upon both of those things or multiple things that have been selected. Now, foreign keys relate one table to another, and you'll be seeing this quite a bit today. A foreign key must reference a primary key in another table. This creates your one-to-one relationship, your one-to-many, or your many-to-many relationships. The relationship is always determined by the primary key and a foreign key, and there's a very easy way to do it, and I'll show you that today so you can always get your points. So let's look at some Cambridge questions and sharpen this skill through application. And here's our first Cambridge question. It says the normalized relational database sports club has the following table design. So they have already normalized it for us. So we have member. What is the primary key of the member table? Well, that is member ID. Notice it is underlined. It is common practice to put the primary key first and to underline it. Does it have to be first? Absolutely not, but it's common practice too. So we want to follow the same format that Cambridge is going to give us. So when we give our answers and we identify our primary keys, we need to put it first and we need to make sure it's underlined. We have the session table, has a primary key, session ID. We have the trainer table with trainer ID as the primary key. Now, because this is normalized, we can see that all these other attributes are dependent upon the primary key. First name, last name, membership type are all part of member ID. The description of the session date, the session time, the number of members, that all belongs to session ID because all those things are related about information about the session. And then the trainer ID, what is related to that? Well, that would be trainer first name, trainer last name. So all of that is completely acceptable and it is normalized as Cambridge has told us. Now, look at the next one, member session. Here we don't have what we call a primary key. We do have a primary key. We call it a composite key. So what's the difference? A composite key is made up of more than one attribute or one column. So we're using member ID and session ID, and the same thing down here at the bottom with session trainer. Now let's take a look at the question. Anushka has designed an entity relationship diagram for sports club. Complete the entity relationship, the ER diagram. So this is where the entity relationship diagrams come in. You'll notice those symbols. This is a 1. Anytime you have a single line connecting to any table, that represents a 1. Anytime you see what my students like to call the crow's foot, that's a many symbol. So this shows a one-to-many relationship between member and member session. And we can see a one-to-many relationship between session and session trainer. But how did they get there? How did this come in to play? How did they get that relationship? Well, we take a look at member, because we know we have a one-to-many relationship. Member ID. How many times will a member ID appear in the member table? Well, if we follow the rules of a primary key, the member ID should only appear one time. So that has to be a unique value. That's where they get the 1 from. Now, member session. How do I relate member and member session? Well, I look for member session and I see member ID. Now notice member ID is not the sole primary key. We have a composite key. That means it is okay if member ID shows up many times, and a member can attend more than one session. That would be a terrible gym membership to join and you can only do one session and then you're done. That would be a terrible gym, or in this case sports club membership. So that's where they get the one-to-many. Member ID and session ID, when you combine both of those together, those values together must be unique. So if I do member ID of 1 and I join session ID 5, that's going to appear one time in the table. It will appear never again, because a composite key, like a primary key, they must be unique values. They cannot be repeated. So that's for that one. Now, let's take a look at session and session trainer. How are they related? Well, I look at my session table, I see session ID. How is it related? It's combined with session ID. Now, session ID, just like member ID in the last example, is a foreign key inside the session trainer table. It is a foreign key. We don't say that session ID is a foreign key. Session ID in the session table is a primary key. We are relating session and the trainer table together with a foreign key, session ID. How many times will session ID in the session table show up for the primary key? 1. That's why we get this 1 symbol. How many times can session ID show up in the session trainer? Can show up multiple times, and that's why we have the one-to-many. Session ID in the session trainer table can show up multiple times because we have a composite key, not a single primary key. It makes no sense to have session ID as a primary key without trainer ID at all. Now what we need to do is we need to take a look at the next relationship. Make sure you'll notice session ID appears in 2 tables here. So you'll see this is session trainer. I forgot to point that out. So you want to make sure you're looking at the right table and not the wrong table. So that brings us to the next one. So how do we combine, here we go. How do we combine the session trainer and trainer? Well, I look in the trainer table, I have trainer ID. How many times can that appear in the table? That's going to appear just one single time. So that's going to give me a one relationship. But now I got to look to see session trainer, because I need to show how these are related. And they are related because trainer ID is my primary key. Trainer ID down here in blue, that's my foreign key. It creates a relationship between these. What kind of relationship? A one-to-many relationship. Trainer ID can only appear one time because each primary key value must be unique. Down here, it's not trainer ID as a primary key. It's trainer ID and session ID. So both of those values showing up in a row must be unique. So trainer ID can show up many times. That creates a one-to-many relationship. Now there is one more. You may be looking and you're like, oh, that's 2 points. One for connecting trainer to session and doing it correctly with one-to-many. But there's actually another relationship. Session ID also shows up in the member session table. So session ID is a primary key. We know it's only going to appear once. Session ID down here is a foreign key that combines the session and members together. So we have session ID and member session. We're going to combine those together. So all we're going to do is we're going to draw that symbol here. We have our symbol, and you want to try to make right angles. Cambridge always does, so we want to try to do the same. I would stay away from a diagonal line. I've never seen anybody say marks will be given off for it, but let's just make it right angles, just like Cambridge is going to do. Now, it's a one-to-many relationship, so I want to make sure I draw that crow's foot, and then we've picked up 2 points for that table. A social media website has a relational database, web data, that stores the site's information. The database has 3 tables to store users' details and details of the images and text that they post. So we have 3 tables: user, photo, text post, and we can see they have already identified the primary keys for us: username, photo ID, post ID. The question: explain how the relationship between the tables user and photo has been implemented. So primary keys, foreign keys are always going to show up with the database questions, and they're usually going to tie them with entity relationship diagrams. But let's handle this question first. You'll notice it's worth 2 points, and that's because there are 2 words that you have to use. So I look for my user table. Here it is. I look for my photo table. Here it is. What I have to do now is figure out, how did they relate these tables together? Well, I know they had to use a primary key and a foreign key. I'll check the user table first. I see username. I'll look in the photo table. Do I see username? Yes, I do. My username in green, that is the primary key. My username in blue down here, that is a foreign key. That's how the tables are linked together, and I simply put that in my answer. Username is the primary key in the user table and appears in the photo table as a foreign key linking the 2 tables together. It is that simple and that easy to pick up 2 points, but you must use the word primary key. Identify what table the primary key is in. You must use the word foreign key and show what table that is in. And I have done that here. Let's take a look at the next question. The database has been normalized to third normal form. Define the 3 stages of database normalization. So here we have 1NF, which is first normal form, 2NF, which is second normal form, and 3NF, which is third normal form. This is simply the definitions for how you know or determine what form it is in. Well, for first normal form, we said there must be no repeating or similar attributes in the table. Each attribute contains only single values and no repeating values. For second normal form, there are no partial dependencies on the primary key. If you use the word partial dependencies, they're going to love you for it and be a lot more likely to give you your point. And then for third normal form, you want to use the word transitive. There are no transitive dependencies. Each non-key is dependent upon the primary key. Now we're going to look at transitive dependencies here in a little bit. When we take a look at a question, I'll show you what a transitive dependency actually is. Draw the entity relationship diagram to show the relationship between the 3 tables. This is a common question that shows up. Sometimes you'll see, like we did in the first question we did today, where the tables are drawn for you. Here, you got nothing. You need to draw all of them. And that's okay. We can handle that. That's nothing that we can't handle. We'll be able to do it without an issue. So we look at the table user has a primary key username. Now, we already said it appears inside the photo table. But now I need to check text post. Does that show up inside the text post table? Yes, it does. Username shows up. If I look for photo ID doesn't show up anywhere inside text post. So photo and text post are not related together, but user and photo are related. User and text post are related. So what I do is I put those down on my sheet of paper. I put my user, I put photo, and I put text post. It doesn't matter if photo is on the left or the right. You can put those in any order you want. It is common practice to put the one that is related to both of these in the middle, and that's what I've done with the user table. All I need to do now is draw my one-to-one, my one-to-many, or many-to-many relationships. So I take a look at user. How many times can username appear inside that table? Well, following the primary key rules, we know those values must be unique. So it's going to be a one relationship. A one to what? Well, how many times can username appear inside photo? Username is a foreign key inside photo and is not a primary key inside the photo table. Because it's not a primary key, it can appear as many times as it wants, and that creates a one-to-many relationship. Now, I need to connect user and text post. Username, how many times can that show up in the user table? Well, we just said one time. A one to what? Well, let's take a look at text post. Text post, username is not a primary key, which means it can show up as many times as it wants. That creates a one-to-many relationship. And now I've picked up all points for that question. Let's take a look at the next question. A database has been designed to store data about salespersons and the products they have sold. There's a lot of information going on here. The following facts help to define the structure of the database. Each salesperson works in a particular shop. Each salesperson has a unique first name. That tells me right away that we can use their name, their first name, as a primary key because it's unique. Each shop has one or more salespersons. Each product which is sold is manufactured by one company only. Each salesperson can sell any of the products. The number of products that each salesperson has sold is recorded. The table shop sells was the first attempt at designing the database, and when I'm looking at it, they have done a terrible job. This person has no business designing a database, but you got to start somewhere, you know. And so we can see Nick, Sean, John, the shop they work at, the products, how many products they've sold, and the manufacturers of those products that have nothing to do with the name at all. And that brings us to the first question. State why the table is not in first normal form. So there are big three red flags here: product name, number of products, and manufacturer that violate the rule. The rule is there must be single values for those attributes. If I look under product name, I don't have television set, then on another row refrigerator, and then on another row digital camera. I have all of those in one. You cannot do that. There are multiple values for product name, number of products, and manufacturer rather than single atomic values that you have here. So that's an easy 1-point question. Let's take a look at the next part that relates to this. I have a feeling that Cambridge is going to be bringing these type of questions back because it really forces students to go through and normalize it all the way. So I have a strong feeling we're going to start seeing these again in the next couple of years. Even if you don't see these, going through this question will really prepare you to help you understand normalization, help understand how relationships are formed between tables, and set you up for success. But let's move on to the next part. So here it says, using the data given in the first attempt, shop sells, show how these data are now stored in the revised table design. So here we have salesperson with first name as the primary key, which is allowed because it is unique in the shop they work at. Then we have a composite key, first name and product name. Those are composite keys with first name being a foreign key down in the sales products table, number of products, manufacturer. But they want to show how these tables are the data is now stored. Well, I don't need repeating names. For the salesperson table, I have a first name. I don't need anything else. I just need the first name in the shop. First name is Nick. The second name is Sean. The third name is John. Now all I got to do is show what shop they work at. Nick works at TX, Sean BH, and John TX. Now let's move on to the sales products table so we can get that filled out. Now I'm going to need all that information that we just crossed out to fill out the sales products table. So I have the first name. Well, that's going to be Nick. Now remember, I can only have single values in each of these rows. So I see that he sold a television set. He sold 3 of them, and that TV is manufactured by SKC. Here we have what Cambridge is trying to set up as a transitive dependency. It's actually a partial dependency, but they're trying to set it up as a transitive dependency. Manufacturer has nothing to do with the first name. We need to know the product name and who sold it. We need to know how many products they sold because we're going to need to pay them most likely, which is why we have the database. But the manufacturer has nothing to do with the product name or with the first name. First name is a composite key with product name. They are a composite key together. So we actually have a partial dependency, but Cambridge is trying to set it up as a transitive dependency. What they're saying is that you can know the first name of who sold the product by knowing if you know the manufacturer, you can tie it back to the product, and when you know the product, you can know who sold it. That's technically what they're trying to set up, but it's actually a partial dependency because first name and product name are composite key. We'll take a look at that in a moment. Let's continue though. Nick also sold a refrigerator. He sold 2 of them, and that is manufactured by WP. Nick also sold a digital camera. He sold 6 of them, and that's manufactured by HKC. And I keep filling the table out like that, and I wind up with something that looks like this, where it's all filled in, and then I have my points. Let's take a look at the next part of the question that ties this together. And here's that composite key that I'm talking about. It says, using the data given in the first attempt table, shop cells, show how these data are now stored in the revised table designs. So I do the same thing I've been doing pretty much through this video. I look for the primary key, I look for the foreign key, I identify which table they're in, and show they're linked together. So I see first name is my primary key in the salesperson table. It is part of the composite key in sales products, which means it can show up many times. So we have a one-to-many relationship here, but they want us to use those words primary key and foreign key. So first name is the primary key in the salesperson table. First name also appears in the sales products table, which acts as a foreign key linking the 2 tables together. That's a question they like to recycle, just with different scenarios and different table names. So if you see that on your exam, be fully prepared to earn 2 points towards that. Okay, this question, this was Cambridge's first shot at 9608 writing this question. It says, explain why the sales products table is not in third normal form. Well, technically, it's not even in second normal form because you have a partial dependency. So manufacturer, third normal form, all non-keys are dependent upon the primary key. So I want to answer this question in that regard. So we're going to. Manufacturer is a non-key, so I'm identifying that manufacturer is a non-key that is not dependent upon the primary key, which is first name and product name, I think. Let's go back. First name and product name. Manufacturer is dependent upon the product and not the first name, which is part of the composite key. So that allows me to answer that question. But again, it's technically not even in second normal form because we have a partial dependency. And that's okay. Sometimes Cambridge is going to make mistakes. I mean, we have humans writing these. Humans make mistakes. It's not a big deal. So it's going to be okay. Write the table definitions to give the database in third normal form. So we need to get rid of all non-key dependencies. So here's what we do. We do salesperson. That's already done for us, first name and shop. that is part of the table definitions that we need to give to show it in third normal form. But then what I need to do is I need to separate the product and the manufacturer. So I have product name, I have manufacturer. I'm going to put those together with product name being as my primary key. Manufacturer can't be a primary key because there's manufacturers produce many different ones. And when we look at the table, we can see manufacturer names showing up quite a few different times. What we need to do now is tie salesperson and product together. How do we tie that information together? Well, I use my two primary keys, first name, product name, and I reference them or put them as foreign keys in my third table, first name, product name. I've created a composite key, and now number of products is referenced by both of those primary keys, because the first name tells me who sold or what product they sold and how many of those products they sold. I need to know the number of products so I can pay the person. I also need to update my inventory with the product name. So this was one of the first questions Cambridge ever wrote for 9608. It does carry into 9618. I think we'll start seeing more of these. Hope you guys found this video helpful. If you did, please be helpful and give it a thumbs up and subscribe to help the channel grow. As always, more review videos are on the way, and we'll see you guys in that next video.